Alright, welcome back. We're talking about 4.4 applications of system of equations. So down below there's a kind of a protocol process to go through when you come across a story problem that is going to involve a system of equations. I've kind of summarized it here. Read it below though, a little bit more in depth. When you go through these steps, the first thing that you want to do is read through the entire problem. Don't worry about writing anything down, just read through and ask yourself at the end of the problem, what is it that they're asking me or what am I looking for? Right? If you don't know, go back and read the problem again until it's clear what you're looking for. It's all too often that people jump into a problem and just start writing stuff down, and then by the time that they've gotten everything written down, they don't even know what they're looking for, so they try to create an equation, but they don't know what the equation is supposed to even express. So try to understand exactly what's going on before you do anything. After that, then you can gather all the information, write down anything that you feel is important. And then with that information, create the system. And you can create one, in this case, we're probably going to be creating two equations for each of our problems. But that's what the system is going to be, is either the two, or as you get more into it, 3 and 4 different problems or equations to express one scenario. And then solve it, solve that system. You're solving the purely mathematical expression of what's going on. And once you've got that, then you can check it, make sure your answer works, and also make sure your answer makes sense. If you run across a problem that says, you know, Mary is so old and her grandma's this much older than she was 10 years ago, kind of a thing, and your solution boils down to Mary must be 23 and her grandma's negative 80, maybe something went wrong, right? So make sure not only that it works for the mathematical system, but that it also makes sense for the problem that you're dealing with, right? And then of course, it doesn't say it here, but number 6, you would then state your answer or state your solution to the problem in terms of the problem, right? If there's a question about interest and it says Mary needs to put so much money in one account and so much money in a second account, how much money should she put in? And then your answer is X is 200 and Y is 500. I don't know what that means, right? $200 into one of the accounts, $500 into the other account. Make sure that it's clear what your answer actually means and is intended, right? So let's take a couple of problems. We'll go through some samples of these. Let's say that we have the sum of two numbers. Is 25, while the difference of those two numbers is 5. Right? And the question here is, what are those numbers? Not very story-esque, it's just, hey, there's a number, here's a number, we got to figure out those numbers, right? But what are those numbers? But we'll get into some that are more story-esque, story problems, right? And so I just want to start by writing two equations. My first equation comes from the first sentence. The sum of those two numbers is 25. I don't know what those numbers are. I can't relate one to the other, so I have to have two variables. So I have x plus y equals 25, right? The other equation comes from the other statement. The difference of those two numbers is 5. So that is to say x minus y is equal to 5. And this is my system. Two equations that describe my scenario. I just have to figure out what x is and what y is, and I'm done, right? But this, you'll recognize, is very much set up to be an elimination problem. If I add the left-hand sides, I get a 2x, and my y's are eliminated. If I add the right-hand side, I get a 30. And if I divide by 2, I found one of my numbers already is 15. Right? There's no translation at this point because there's not a great story, right? There's two numbers. Well, one of them's 15, right? What's the other one? Well, I plug it into here. X is 15, so 15 plus y equals 25. Well, if I subtract 15 from both sides, I get y is 10, right? And you can verify this. 15 plus 10 is indeed 25, so the sum of those two numbers is 25. The difference of those numbers is 5. It works out. Those are my two numbers, 15 and 10. Good. All right, let's look at the example from the reading down below. It says American Rentals charges $40 per day for a car rental. So they charge $40 per day. Plus 25 cents per mile. Okay. This is one, so this is American. That's one company, and then we have another company, Bowman Auto. Charges $30 per day for the rental car in addition to 50 cents per mile. So they charge $30 per day. Plus 50 cents per mile. Okay? Yeah. And Harry rents a car from American Rentals and pays $170. So Harry comes in. From American Rentals and pays $170. Right. And Susan rents a car from Bowman. So Susan rents from Bowman and pays $190. Okay. If Harry and Susan rented the cars for the same number of days and drove the same number of miles, find the number of days the cars were rented and for how many miles they were driven. And that's the key that makes these two relatable, is that I can call X the number of miles, and that X is for both of these scenarios. X, we're going to say, is the number of miles driven, which again is the same for Harry and for Susan. If it wasn't, this would not be a system that I could really put together with two equations, right? But then we also have, let's say, Y is the number of days rented. And with this information then, they're asking us to figure out what X and Y are, the number of miles driven and the number of days that they were rented for. And I can create those two equations. Those two equations are Harry's equation. Harry rented from whatever A was, American Rentals, doesn't matter. He rented from these guys, right? And he rented for $40 per day, so that's Y. So for Harry it was 40 multiplied by Y. Plus, and I wrote these probably different from what I'm looking at the example down below. It doesn't really matter which one of these you just define to be X or Y. But since I defined number of days to be Y, I'm going to put $40 per day as 40Y. Plus this 25 cents per mile, and I'm just going to put the X first because why not? We're just kind of used to that kind of a thing. But 25 cents per mile driven times the number of miles driven plus $40 per day multiplied by the number of days is his total cost, which is $170. Likewise, Susan has an equation. She is paying 50 cents per mile, so that's 0.5 times X. Plus, but she's doing $30 per day, so 30Y. And she paid $190. Okay. Now, this doesn't look terrible, I've got these decimals here that, you know, people may not like a lot. But it's not too bad. And I'm going to take this and throw it up to the top so that I can manipulate it a little bit. So if you need to write any of this down, do it, because here it goes. Remember, because when I erase this, I'll probably forget x is miles. I'm going to write it here. X is miles. And y is days. All right. All right, so I have 0.25x plus 40y is equal to 170. And I have 0.5x plus 30y equals 190. Okay. Now there's a lot of things that I can do here. I can multiply everything by 100 if I wanted to get rid of the decimals, or I can just deal with the decimals. And if I just deal with the decimals, right, I know that 0.5 is double 0.25, right? And so if I actually just come up here and multiply this top equation by -2, and I write it right there, right? If I multiply by -2, I get -0.5x, which is convenient because if I can add these two together, my x's are going to disappear on me. -2 times 40 is, so I get -80y, and -2 times 170 is -340. Right? I'm going to add these two equations together, those two. Because 0.5x and -0.5x, again, that disappears, and I get 0 x's. 30 minus 80 is -50y. And then 190 minus 340 is -250. 150, right? And then I just divide each side by -50. The negatives cancel out, the 50s cancel out, leaving me with y. That gives me 3. Y was days, and so each of these, Susan and Joe, or whoever this guy is, I don't know, I don't care, 3 days, right? They rented it for 3 days. I can take this 3 days and plug it into one of these to figure out the miles as well. So I'm going to plug it into, it doesn't matter, I'll plug it into the top one. So into the top one gives me 0.25x plus 40 times y, which is 3, is equal to 170. Right. That is to say 0.25x plus 120 equals 170, right? I'm going to subtract 120 from both sides here, so that gives me 0.25x, gives me 50, right? And then if I divide by 0.25, it gives me x on the left and 200. So they drove 200 miles. And rented for 3 days. All right, good. All right, let's take a look at the next example right below. We have 2 cell phone companies with names that scream, "Don't sue me." We have Jingular Wireless. And they charge $20 per month. Plus 5 cents per minute. This is how cell phone companies used to. They haven't done this for years, decades probably, but way back when they started, they would give you super low monthly charges and then charge you for the amount of actual phone time you use, so people would call and be as quick as they could and hang up as fast as they could. Nowadays, your cell phone bill is probably $100 and some odd, because why not? And then we have G-Mobile. G-Mobile. Charges $15 a month. And 9 cents per minute. And then the question here says, at what number of minutes will the two plans have the same cost? Okay. All right, so we have two costs here, right? And I want to know when this cost is going to be the same. So I'm going to express both of these as the cost of plan 1, the cost of plan 2. Since I want this cost to be the same, I'm going to use the same variable, and it's just C. But the cost of my Jingular wireless is $20 per month. We're looking for a monthly charge, so I don't need another variable. I just need the $20 because we're looking for the monthly cost. So there's not an unknown number of months, we're just looking at one. But I pay $20 plus 0.05 multiplied by x, where x is the number of minutes. If you want, you can call this m. That way when you're done, I'm going to have to erase my board probably, so in the end, when I solve for m, I know, oh, that's the number of minutes, right? The other equation here is 15 plus 0.09 m, right? And that's my system. The cost of plan 1, which I want to be the overall same as the other cost here, is equal to 20 plus 5 cents multiplied by the minutes. And the cost of plan 2 is 15 plus 0.09 m, right? Now, this is perfectly set up for a substitution. Since my cost is equivalent to this expression, I can take that expression and replace the cost in the other equation with it. So then the final single equation becomes 20 plus 0.05 m. When is that equal to 15 plus 0.09 m, right? Which a few sections ago, a few chapters ago, in chapter, I don't know, 1 or 2, we probably would have just set this up and skipped the system altogether. We would have said the cost of plan 1 is equal to the cost of plan 2, and there's only one variable. So we kind of would have sidestepped this to begin with. But I want to solve this, so I'm going to move my m's to the right-hand side because 0.05 is smaller than 0.09. And since those are going to the right, I'm going to subtract 15 from both sides. So that gives me 5 equals 0.04 m. And if I divide by 0.04, that gives me an m on the right-hand side alone, and 125, maybe. Yep, 125 minutes. Yep. And that's the question. The question was, I don't think I may have not have iterated this very well, but the question was how many minutes of talk time per month would these two plans be the same? That happens at 125. Good. Okay, let's look at this guy. An investment specialist has $8,000 of a client's money. So we have $8,000 total invested. And they're splitting this into two accounts. One account earns 6% interest. Simple interest. And then we have another account earning 9%. Okay. If at the end of 1 year, the interest, total interest is $660. How much was invested into each account? Okay. So I've got two amounts. I have X number of dollars going into my 6%, and I have Y going into my 9%, right? And you might also recognize that maybe a chapter ago, I can't recall which section it was, but we would have said, well, instead of calling this Y, why don't we call it 8,000 minus X, right? Since we're dealing with systems here, we're going to actually create the system, and on our first step solving the system, we'll see where that 8,000 minus X comes into play. But let's create the system for now. The system is, essentially, I have two equations. The amount that goes into account 1 plus the amount that goes into account 2 has to be $8,000. That's how much money is being invested. Okay. The other one is that my total interest is $660. That is to say, the interest from account 1, I'll write this over here. The interest from account 1 plus the interest from account 2 is total $660. Right? This is simple interest. We're talking about simple interest being the principal multiplied by the rate multiplied by the time, but this time is 1 year, so I'm just going to not even write it because principal times rate times 1 is then just principal times the rate. So the interest from account 1 is the principal in account 1, which is X, multiplied by the rate, which is 0.06. So I can write this as 0.06X. The interest from account 2 is the principal in account 2 multiplied by the rate, so 0.09Y. And that totals $660. And that's my system. Right? And it's really easy to set this one up for a substitution by subtracting, say, X from both sides. Right? If I do that, I'll write this over here. Subtracting X on both sides gives me this Y equals 8,000 minus X, which is another justification for when we did this a couple of sections ago, why we just said, let's just call Y 8,000 minus X. And if I plug that into here, then I get the equation that we built a few sections ago, 0.06X plus 0.09 times this 8,000 minus X equals the 660. Right? I solve for my X, and then I'll plug it back in and solve for my Y. I'm running out of room here, so if you need to write this down, do it, because I'm erasing it so that I can move up. So this gives me 0.06X plus 0.09 multiplied by my 8,000 minus X is equal to 660. Okay. I'm going to distribute this 0.09. So I get 0.06X plus 7,200 with yoink yoink, so 72, minus 0.09X equals 660. And double check this. Oh, it's 720. Yeah, that's right. 720. Okay. I can combine my x terms on the left-hand side. 0.06 and negative 0.09 gives me negative 0.03. Subtract 720 from both sides. And again, negative 0.03x equals negative 120. Or sorry, negative 60. And then if I divide each side by negative 0.03, I have x isolated. This turns into $2,000. And that, I forget which account that was. Refer back if you're writing notes, or rewind 45 seconds ago. $2,000, I think, into the 6% interest account, right? And then of course, y is the difference between 8,000 and 2,000, so plugging it back in, we should find that 6,000 should go into the, I want to say 9% account. All right, good. All right. This next type of problem I've seen on a final exam every year for the last like 10 years. So let's take a look at this one. Adult tickets at a theater, $7.50 each. While children's tickets cost $4.75. The theater manager notices that there's a total of 160 tickets total. And the revenue was $1,090. Okay. How many adult tickets and how many children's tickets were sold? All right. So let's look. I have 160 tickets total, and I have two types of tickets, adults and children's. So the first equation I'm going to write is A plus C for the number of adult tickets sold added to the number of children's tickets sold should be a total of 160. Right? The total number of tickets sold, which is adults plus children, equals 160. The next equation deals with this money, right? $1,090. How did we get there? Well, we sold A multiplied by 7.5. $7.50 multiplied by the number of adult tickets. And that's the amount of money we pull in from adult tickets. Plus 4.75 multiplied by the number of children's tickets. The amount we sell them for times the number of them gives us a total dollar amount for the adult tickets plus the children's tickets. Altogether, that's $1,090. And I have a system, right? That's my system. All I have to do is solve this, right? Now we're dealing with decimals. If you don't like decimals, you can multiply by 100 to get rid of them here. It's not a great idea because if you multiply this by 100, you're multiplying this by 100 as well, and you have a million, or well, a 10,000, 100,000. Yeah. 109,000 that's sitting here, and it's equally ugly, right? So what I would do is set this up for either an elimination with the first one, because it's really easy to just come in here and do that, you know, C equals 160 minus A, right? And then just plug it into here. Or you can set this up to eliminate. You can multiply the top one by negative 4.75 to eliminate your C's, or you can multiply it by negative 7.5 to eliminate your A's. I'm going to go with the substitution method because it's easy. That gives me 7.5A plus 4.75 multiplied by, instead of C, now it's 160 minus A. That is equal to 1,090. Right? Distribute this 4.75, that gives me 7.5A plus, I don't know this one, I'm not gonna try, 4.75 times 160, 760. Minus 4.75A is equal to 1090. I can combine my 7.5A and minus 4.75A. That becomes, I'm gonna do that one here too. That's 4.75, 2.75. Plus the 760 is equal to 1090. And then of course subtract 760 from both sides. So that gives me 2.75A on the left equals 330 on the right. Running out of space on my screen here, but I'm going to divide each side by 2.75. And I'm going to end up with A, the number of adult tickets is 120. So I have 120 adult tickets. 120 plus what is 160? It shouldn't be terribly difficult to plug that 120 in. 160 minus 120, I have 40 children's tickets. And again, I've seen this problem on every single final for so many years, so know how to do a problem like this. Okay, let's look at one more type of problem here. A chemist needs a 120 liters of a 30% solution of acid or whatever it is. Could be a nurse needing glucose or saline. He has 20% and 50% available. And then the question is, how much of each of these, 20% and 50%, should he use? Okay. Again, I'm going to set up two equations, right? I'm going to identify my unknown here. X is the amount in liters of the 20% solution, while Y is the amount in liters of the 50% solution, right? That's the idea here, and the amount of the 20% that he adds to the 50%, right? The amount of the 20% plus the amount of the 50% should be the total amount that he wants, and that's 120. Right? And that's my first, that's the easy equation. The other one is just these concentrates. 20% of X, or 0.2X, plus 50% of Y should be equal to 30% of 120. Right? So the top one is volume. The amount that he puts from bucket 1 plus the amount that he puts from bucket 2 should be the total amount that it needs in the end. And the bottom one is about pure acid. 20% of the amount from bucket 1 is actually acid. 50% of the amount in bucket 2 is actually acid. And 30% of the 120 liters in the end is actual acid. The amount of acid from bucket 1 plus the amount of acid from bucket 2 should be the amount of acid in the end, right? And this is my system. And if I'm doing this system, you can set this up easy enough to do a substitution, right? Let's do this one not as a substitution though. What I'm going to do is multiply this equation by negative 0.2. I'm going to set this up for an elimination. Because negative 0.2 times x is negative 0.2x minus 0.2y, and then equals negative 24. Whereas I can simplify this 0.3 times 120, that gives me 36. So I'm going to write that here in place. This is 36. And now I've set it up to combine these two equations and eliminate my x. I still have to deal with decimals, but I'm not scared, right? I can deal with this. 0.2x minus 0.2x, gone. 0.5y minus 0.2y, 0.3y. Equals, over here, 8, not 8, 12. And then divide everything by 0.3. That gives me y equals 40. And so I should be using 40 liters of, and if you recall, we said the y was the amount of 50%. So 40 liters of 50% acid. The difference, 120 minus that 40, that gives us x is 80 liters of the 20% solution. And we have our solution. All right, this was probably one of the longer videos. Appreciate you hanging in there. I will see you guys for the next section.